Uh, Hello everyone. I am Jayavardhan Shukla, and I have created Steel IQ, which is the predictive maintenance and downtime intelligence built for Tata Steel AI Hackathon Round 2. This platform is deployed live on Google Cloud, and what you're looking at right now is a production instance and not a mockup or a slide deck. So firstly, we'll talk about the KPI strip right here. So it's basically gives leadership and engineers the same live snapshot, like how many alerts are open right now, what is the plant's downtime exposure looks like in rupees, and how the equipment health is trending across the site. So this matters because the maintenance decisions at Tata Steel don't happen in isolation. A vibration spike on one motor can mean something very different depending upon which line it's on, what production is running, and what the downstream cost of a stoppage actually is. So I'm staring right down at the command center, which is the engineer's primary workspace. So the platform has basically it has multiple entry routes. There are four routes: engineer, supervisor, planner, and executive. Each of them has a separate accessibility over certain features. So right on the top left is basically you see a TSCR finishing line map. It's a spatial view of the line, and assets with active alerts are highlighted so you know immediately where the attention is needed. So currently, the three assets are basically highlighted where the attention is most required. They are marked as critical, and the other ones are marked as low priority or the green ones. Below that, the sensor spark lines are pulling live vibration and temperature trends for the selected equipment. I have got TSJ, TSCR F4 MTR 001 selected. That is the F4 stand main drive motor, and the ISA instrumentation on this asset includes VT701A for vibration and TT701B for temperature. These are in generic placeholder tags. This is Tata Steel Jamshedpur nomenclature aligned to how the plant actually names and instruments its equipment. So, Steel IQ supports two interaction modes here, the chat or the voice. The chatbot basically communicates through both of these methods. The voice uses Gemini Live bidirectional API for hands free queries on the shop floor. An engineer standing next to running equipment doesn't have to type on a tablet. Chat runs on a full multi agent diagnostic pipeline, which is what I'm going to demonstrate now. I'm gonna send the core incident from the problem statement. That is the F4 stand motor has high vibration on VT701A and overheating on TT701B, and I want a root cause analysis and a maintenance plan. So there are certain pre-built queries for the same. So I can simply click on any of them, and it automatically fills my tab. And I click on send, so you can see the multi-agent pipeline runs, and it completes and shows the critical vulnerability report. So this report is for engineer to analyze what the problem is, along with the verifiable evidences and long-term monitoring situation. So we have an ML model, isolation forest, which is an unsupervised model running, which is used for calculating the RUL, plant priority, and the estimated downtime exposure. So these three variables are basically calculated on the basis of the plant's data. So sorry, the equipment's data. Each equipment has multiple input data streams, like the sensor, the log reports, and so on and so forth. Each equipment has different report like that. So on the basis of that, this assessment is calculated. So each time we run a query, this model is basically invoked by the agent, one of our agents, and it basically calculates all of these certain values. Along with that, it also gives the assessment and the top root cause for this, like why the bearing is due to which reason. Certainly it tells that it's due to inadequate lubrication interval, and we have to see decision panel for risk breakdown, evidence, and monitoring. We can see that all of our seven agents are invoked one by one to give the final response. Along with that, there are various edge cases which are also handled by the orchestrator agent, so that we can talk about later. So we can select of what equipment we have to basically provide an update on or give an insight on right from here. So an engineer can choose an equipment and basically choose to talk or basically chat with the system right here. So voice is also enabled here. Voice basically uses bidirectional API. So it says voice session ready. So currently tell me what sort of precaution measure do I need? Should I oil the equipment so that it becomes correct? So this is what it is. I just showed you a demonstration of how the voice capability looks like. It is a continuous one two-way interaction. So I speak to the voice chat replies to me, and so the communication happens both ways. So you can see also there are follow-up questions right here. So I can simply click on a follow-up question and then click on send. So it automatically sends the follow-up question. Now other thing here to note that is that if the question or the chat I provide to the chatbot here right now is not making sense to the current RAG pipeline or the LLM pipeline, it basically asks for basically fallback question two times before basically concluding that the situation is not under its control. So this fallback is basically kept in place because there are multiple times where the situation where a question requires follow up clearance questions as well. So that's why we have keep this fallback loop in place. So there are feedback loops here. We can basically confirm the root cause, and then basically confirm after confirming the root cause, it basically gets saved into the memory space. So basically we can see what's the root cause for this, and necessary precaution can be taken. So this is about the command center. Next one is the equipment health. So basically equipment health is a space where we can see the health of all of our assets right in a single go. So we can choose whatever equipment we have right now, and we can see its current risk score, the anomaly, and the RUL. So these are all the critical equipments right here, along with its sensor trends. So for sensor trend, we have simulation going on, which is a continuous simulation over the Google Cloud platform, and the data is basically fetched through this in the form of different sensory inputs. So like there are 14 different methods suggested in the problem statement, which you have taken here. The delay logs, fault error messages, failure analysis reports, incident breakdown reports, sensor data summaries, anomaly alerts, and so on and so forth. Now all these 14 inputs are not applicable to certain different equipment types. So only certain inputs are available per equipment type, which we can see. For instance, in the case of a blast furnace, there are five different ISA instruments which are there. We can click on any of these instruments to basically see the live data. So uh, we can basically sort the data from and to, and can get the CSV report for the same. I have downloaded a CSV report for this reference. You can see this is the CSV report that I downloaded. It shows the timestamp, equipment ID, other different fields, along with the vibration, temperature, pressure, and power value, and whether this particular combination is an potential anomaly or not. So currently, I have only downloaded the anomaly data. We also have an option to save this particular CSV on the Google skills, and we have certain ML skills. ML skills is nothing but a particular platform from where we can register our model endpoints right into our system. So we can feed our model endpoints here, and we can run our ML models which are deployed onto the Tata Steel's cloud platform into here. So for instance, right now I have one ML model which is used for anomaly predictor and the performance. So basically we can use this particular data that we have. We can enable for this asset, and we can export and analyze, so we can see what results does this give. So we can see that the results are exported to our signed GCS path in a specific CSV. So the model analysis says that the current operating band is normal. It has a confidence score of around 585, and it says that the remaining useful life for this equipment is 136 days. So by using this particular specific ML skill, we can predict the remaining useful life of this equipment, along with specific recommendation like continue routine monitoring, no immediate intervention is required, and an anomaly score. So out of the total data, we filter out only the anomaly data in the CSV. That's why we are seeing the anomaly score of 0.087 here. And this is the specific A skill and that we can use. If we add more skills through our ML skill tab, which is right here, we can use more of these skills into any of our equipment's data and run different scenarios from right here as well. So that is one of the features of ML skill. Now next we have next I will show the ML skill directly. So this is one of the skills that was enabled. If for instance, a supervisor and executive wants to enable more of such skills, then they can simply register their model. They have to provide a name, model endpoint, a predictive maintenance post query, like what the JSON response looks like, and this would basically register their model. Now this model, once registered, can be used for any of these equipments. They can simply go for any equipment data and select their model from here. Right now, since only one model is there, so only one model is coming, that is a reference ROL or anomaly predictor. If more than one models are registered, then they would show up right here, and we can simply run the model by clicking on the specific button right here. So this way we can basically run different types of analysis on through ML models for these equipment data right into our platform. The next thing is agent marketplace. So we can see the agent marketplace as a platform where different types of ML agents can be registered. So we know that Tata Steel has a massive store of different AI agents that it is building. Currently it has more than 800 plus agents that are incorporated into its system. All these agents can be brought together into a seamless platform from where these pre-existing agents can be created by a supervisor or an executive in this platform, and these agents can now be worked upon into the current system. So right now I have some pre-configured agent packs like the core maintenance decision pack, the TSCR finishing rolling pack, safety and environment pack, iron making pack, and all these agents can be used for a specific decision related, which can improve the overall understanding, the overall current understanding of our executive system. So for instance, if there is any gas leak happening in a specific instrument, then this particular agent would come into the place. The orchestrator would invoke this agent, and the relevant course of action would be then suggested to the user through our chatbot right here. So this is the use of specific agents. We can basically add more of our agents through this platform into our system. Now the next thing is alert center. We have different alerts that are there, since the simulator pushes data every 50 seconds. So any new alert comes will directly be shown here. We can choose to acknowledge the alert, or we can see what alerts are there. Then there is reports and logbook. So if we want to generate a health briefing, we can choose to generate right from here. It gives a audio as well as a RAG powered shift report, which is an aggregate live report with equipment, health, alert, logbook, and knowledge corpus. So we can choose to play the audio briefing right here, or we can choose to send this audio briefing through an email for any specific equipment. We can simply choose the equipment and the email for the recipient and an optional note, and then we can choose to send a downtime report over email. I have already done that, so I will show the demo downtime report. This is the type of a report that is sent to me. It shows the live downtime exposure in crores of rupees, and the relevant equipment and the projected downtime and the risk category. So it shows that this is a critical risk. So it also gives the full maintenance decision report. This is also obtainable from our command center as well, but it also mails in case any feedback or any upper executive action is required. So in that case, these reports can work. We can also see all the report logbook entries from here. All the previous reports that are generated into our system can be obtained or seen from here. So this is about the Steel IQ platform. The next thing is business impact. So business impact shows the live plant downtime exposure. It shows that the total plant exposure currently is around 182.34 cr. There are 14 degraded assets in our system, and there are 14 unacknowledged alerts as well. So the last check sync is basically shown as a time here. So we can see the exposure by production line. So there are different production lines. The production lines can also be seen from here. There is just one line map or a specific production line. It shows what all equipments are in a critical state in this production line. Similarly, there are other production lines as well, and it shows how much exposure does each of these production line carries. So a Sinter plant is carrying for 2 crore worth of production. A Coke oven is carrying 1 cr worth of exposure, and so on and so forth. The top exposure assets are shown. The blast furnace is currently the topmost exposure, the most critical asset. It has the biggest exposure. So we can select whatever asset we want, and the relevant is shown here. So the live exposure, how it is calculated, is shown. We can see that BFH, which is the blast furnace, is calculated as 25 rupees per liter per hour, 25 liter per hour into 198.5 hours projected of runtime, which basically creates a 49.62 crore exposure, crore INR worth of exposure. So we can also choose to run what would happen if we defer the intervention required for maintaining this equipment. So let's say if we choose to defer the intervention by 42 hours and we run the defer scenario, then it also uses our ML model to basically calculate what would be the later exposure if we choose to defer this by 42 hours. So we can see that the current exposure is 49.27 cr, but after deferring this by 42 hours, the exposure would increase to 67.79 cr, which is a great amount of increment. The increment is total around 18.52 cr. Which also shows that there's a risk multiplier of 1.31x for the delayed intervention on BFH. Similarly, we can also run different scenarios on different equipments right from here. So let's say for this equipment, if we choose to defer it by 24 hours, then it shows that after deferral, the exposure would increase to this much amount, and which is a multiplier of 1.18 times. So this is how we can basically choose to run different scenarios on our platform, along with equipment health and a chatbot integrated right here. So certain features like adding an agent or an ML skill is only applicable to supervisor or an executive. Planner is for planning different scenarios on the business impacts. And yeah, so these are certain sort of features that are there into the Steel IQ platform. The whole platform is a cloud deployed and is ready for scalable operation in any specific plant, or yeah, in any specific plant. So this was Steel IQ. I am Javardhan Shukla signing off. Thank you so much.